Boot. Sarah Boot. Cool. All right. We got 3 days. 3 days together. Tell you some news as soon as we do this first. Oh, so well timed.
Right on time.
Indeed. Or so.
And not even coffee. I'll just step out in the hall for this.
What's this?
I'll just step out in the hall for this.
Okay.
Don't want me chewing or whatever.
All right. You ready? Just settle in for a second. Just feel your body before this bell starts. And then let's see how long we can hear the bell. At some point it starts to be my imagination, I think. Do you hear it like doing that, bouncing back and forth, like kind of moving around?
I
Yeah.
was envisioning it like breath almost.
Yeah, I like that.
But I was also trying to think about what is the frequency of it?
I was too. I was trying to don't get analytical. but-
The first time you hit it, it's pretty loud. So I feel like my head just goes like, just moves side to side.
Really? Like physically, and just like your head's
You-
the
like
bell.
You bend rap, yeah,
Like you know, like on cartoons, like when they like hit
Yeah.
with their head,
Uh-huh.
like really hard, and they just go.
kind of bend. I hear you.
Yeah. I feel like it's
Frequencies took you back.
Yeah.
like if I was like in Tom and Jerry or something.
Wow, that's an old cartoon for you to be
I
referencing.
grew up on that. Tom and Jerry, the Looney Tunes.
Yeah, those are great.
Oh yeah.
You still had those growing up.
Yeah, I guess so. Yeah. I'm about to go down some wormhole. Let's not do it. Let's not do it. Just a quick warm up. I'm going to give you 3 series. Tell me if the series converges or diverges. Don't necessarily need the ratio test for any of those. I got some stuff I want to hand out to you.
The easiest thing, yeah.
Yeah, there's double-sided sheet, so whichever side. You're welcome. There's other stuff.
Oh, is this what you posted on?
Yeah, I just wanted to give you physical copies, so we had them today. And then, let's see, I'll turn Vincent's into an airplane. It's been a while. Let's see if we can get it to him. Throw it off the top floor. It has been a while since I made an airplane. Yeah, if you can, if you, one of them can be about, like, found the sum, is that what you're asking? Yeah, maybe. Yeah, one of them you can find the sum of. Too much body.
Whoa.
That's not, that's actually pretty good. Upside down, but hey.
Must be a firefighter.
Vincent, your handout's in the corner of the room. I'll get it. Do you see Vincent? Like, you guys come in here together, that doesn't mean.
Yeah, I know he went to Texas over Christmas.
I know he emailed me, he said he drove back from Texas, he's exhausted, so he's just gonna watch the recording, but, I just wanted to get him a hand up, but I guess these are available online,
I'll see
Vincent.
him tomorrow, for sure.
Get him one, just pay a lot of money to come to Regis, get all the resources. Let's take another minute. So, last Friday, we spent a lot of time just me giving tips. One of my tips is always write these things out, right? At least grab the first 3 or 4 terms of the series so that it seems a little more real in your brain, because this notation is hard to get a hold of without a lot of practice. So Kevin, what about this one here? What's up with that? Does that converge?
I say so,
So what's your reasoning?
because it's approaching 0.
Do we have other folks agreeing? Converge? We have divergence of opinion?
I agree, it approaches zero. I think it diverges.
I think it diverges. Why do we think it diverges?
Because the P, which is the 1/3,
That's it.
is less than 1.
Yeah, so it's P series. It's P series. P equals 1/3. Is that what you were saying, PK?
Yeah.
You're all over the P series. You got the, yeah, we need a K series. We got a PK series. All right, I'll stop that idiocy. Sorry, PK. I apologize. This is a P series. P equals 1/3, and that is less than 1, so it diverges. So Kevin, one thing to keep an eye out for, just because the terms die out does not mean it converges.
Okay.
So how about this one here? BK, can you help me out? Well, you're doing a lot of work today, I apologize. What kind of series is it?
Geometric.
It's a geometric. We all on that? How do we feel about that? Geometric series? What, how do we know it's a geometric series? What is the key?
The exponent keeps increasing.
The exponent is moving. The exponent's the only moving thing. So that is a geometric series. So from here to here, what do I multiply by? E over pi. Multiply by, I got that common ratio thing going on, right? So compare that to these P series. In a P series, what's moving is the thing you're taking the power of, right? So this part is moving, the exponent is fixed in a P series. So exponent is fixed. This is geometric. Does it converge? What's R?
E over pi.
Yeah. Does this converge? What's E over pi approximately? What's E approximately? What's pi approximately? Anybody?
3.11.
Okay.
2.71.
Hey, there. Oh my goodness, yes. Is that less than 1?
That is.
It is. So this converges. That's a tricky, that's a fun trick one. So that is less than 1. So this converges, and in fact, we could say what it converged to. It's the first term over 1 minus the common ratio, E over pi. You could simplify that to be something even kind of pretty. Multiply top and bottom by pi, and simplify it. So this stuff, I gave you a couple of sheets. One is my clearly my handwritten version. A simple version of just things we've talked about so far. One thing we haven't talked about is the limit comparison test. Don't worry about that. Alexander was by earlier, and I was talking about how we have 3 classes, right? We have this one, we have 2 more, and our final exam is next Wednesday at 1:15. There's so much that I want to do that we're not going to get to. So what I'm trying to figure out is what's going to happen. I think part of your final will be like a take-home thing that I'll give you some, probably be like a homework assignment. You bring that in, and then there'll be a small in-class easier part. But there'll be a few things I want you to do between Friday, whatever. I'll probably give it to you on Wednesday, and you can come on in and we'll work on it. I'll have office hours and all sorts of stuff like that. Does this sound like a reasonable approach? The alternative is the final has things on it that will cover a bit on Wednesday, and I just don't think it's fair to like make you memorize shit. What do you think, Jose? You're thinking deeply.
No, the first one's better. The first option.
I think first option's better. I mean, I deliberately spun it so that it would sound better. So I was like, here's this option, or here's a terrible option.
I have a question. So,
Yes, sir.
The take home part is the finals week that would take it and bring it back like the Friday.
No, it would be due you would come here on Wednesday and hand it in.
Oh, okay, yeah, that's fine.
Because if I give it to you, if I make it Friday, you'll start Friday, or you'll start Thursday, right? Like whenever I fix it, it's just gonna make your life. If the longer we put it off, the longer you're gonna put it off. So let's just get this shit done. And I won't be mean, and I'll actually create some helpful videos, and the test will kind of walk you through some of the things, or at least the take-home part. Does this sound okay?
Yeah.
Yeah.
Okay.
Is it-
You cool with this, Kevin? Okay. Yes.
So is it basically just so the take home part, is it basically like a normal test? But it's just part of it?
I mean, it'll probably be easier than it'll be hard because it's kind of newer stuff,
Right.
but it's stuff I really want you to think about before you leave this class.
Okay.
It'll be more like a learning experience than a like test per se. think homework, guided homework.
Gotcha.
I'm just curious about the in-person part, if slash when you create that.
Yeah,
Is there gonna
I
be-
would let you know Wednesday what that's going to be.
Okay, is it, okay.
But it would not be hard.
I was just curious if you
Yeah.
were gonna provide like what we.
I will provide great guidance,
Okay.
incredible guidance.
Alright.
Does this sound okay?
That sounds
And then we'll just make it all open. You can bring whatever you want except like a computer and a GPT.
None around that
So,
works.
yeah.
Cool.
Are you scared? Are you cool with this plan?
Yeah.
Yeah?
Sweet.
Yeah.
Actually, I had ChatGPT write all my notes. So.
Can I scan things? All right. Yusuke, you got anything on this one for me?
Honestly, it's not really.
Okay, well, that's a fair thing to say.
That's it. Precious one.
It's okay. Anybody feel like they got this one? Kellen, you got anything on this one? Last one?
I think it's divergent by the divergence test.
Perfect.
Yes, okay.
Yeah, exactly. So this is what you were thinking about, Kevin. This is the contrapositive of this is, so we know that if a series converges, I'm just gonna say this one more time, probably the last time, then the terms must die out. But if the terms do not die out, then the series cannot converge. And so this is what Kellen's citing here. This is the divergence test. That if the terms don't shrink to zero, there's no way the sum can be finite. And so here, this is the a sub n. And what is the limit on that as n goes to infinity?
2 sevens?
You're looking at,
What was the question again?
what is the limit of that term? What is the limit of that expression as n goes to infinity?
One. That's what I was trying to find.
1, yeah, it's 1. You were looking at the wrong numbers, Yusuke.
Okay.
But you see, so like when n is very large, adding 2 and adding 7 gets you about the same thing, right? N is 1,000,000,
Yeah.
1,000,000, 2 over 1,000,000, 7, 1. Does that make sense?
Yeah.
Okay, cool. So the a sub n goes to 1, which is not 0. So by the divergence test,
It converts.
it diverges. And so Yusuke, you were, I see where you're coming from thinking this might have been telescoping, but a telescoping series will have a factorable thing in the bottom, like that. So you were kind of thinking the right way, but
Okay.
they have to both be in the bottom.
Okay.
That's when you take the partial sum.
And that's when you do the partial sum stuff and partial fractions.
Yeah.
Cool, good work. All right, so here's the plan for the rest of the semester. Today I want to talk about alternating series. And actually you're gonna like this. These are pretty sweet. Alternating series, probably the easiest kind to deal with. And then on Wednesday, I want to talk about power series and Taylor series. And they're almost the same thing in many ways. We've kind of done a little of this. I hinted at it earlier in some problem we did. And you'll see the similarities when we get there. And then that'll be it. And Fridays will like come work day and consult. All right, so let's talk about alternating series. If I have a series, first let me just write up the general form of it, that has a -1 to an n in it, and then times some term here. And so these a sub n's, we're gonna say are positive expressions. At least they're non-negative, for sure. But this thing, what I'm trying to indicate here is that I've got a1 minus a2 plus a3 minus a4 plus a5 minus a6. So it alternates in sign. It's plus minus plus minus plus minus forever. That's the alternation. That is what is alternating in an alternating series. Or it could be minus plus But the key thing is, every other term is the opposite sign of the previous term. So it's one of those two kinds of forms. If you see that, boy, life is awesome. Life is so good. And I want to give you kind of a proof as to why. And we're going to start with the proof and then we'll come up with the conditions. So let's say I have this first series here. S is this guy, right here. So suppose this is our sum, S. Let's look at the partial sums. So there's A1, S2 is A1 minus A2, S3 is A1 minus A2 plus A3, and then down the chain. The next one's going to have a -4 on it. I want to make some assumption here. We know that this can't converge unless these A's go to 0. So we know that the A sub n's must converge to 0 for this to converge by the divergence test. So they have to die out. And since they're all positive, this part here, this without the signs on them, this is positive, and I'm putting a minus in front of it. This next term, A4 is positive, but I would subtract it off. So for this to converge, so since the A sub n's are greater than 0, they must be decreasing. It must be a decreasing sequence. So in other words, i.e., A1 is bigger than A2, is bigger than A3, is bigger than A4, blah, blah, blah. And those shrink to 0. Eventually that's going to shrink to 0, but each one is smaller than the one before it. Yes, sir?
Are they always going to go to 0?
Yes, they have to, because if they don't, then by the divergence test, if the terms don't die out, the series diverges. So they have to go to 0. Does that make sense?
Yeah.
Yeah? Question, you good? Keep going. Okay, cool. Okay, so now let's make a little picture of these sums. So first off, S1, I'm going to put, this is a number line right here. And I'm going to draw the partial sums on this number line. So the first one, S1, is just whatever A1 is. It's this number right here. Oh, I probably should have started here. Because now S2, I'm going to subtract off something, and that means I move to the left. So if I move A2 units this way, that's S2, which is A1 minus A2. So let me stop there. Take a look at that picture. If this is 1, so if I had something like this, 1 minus a half plus a fourth minus an eighth plus a 16th, S1 is 1. Do a nice concrete 1. And then I subtract off a half. So I move a half, so there's S2. And then S3, I'm going to move to the right because I'm adding something. So S3, we move A3 to the right. So like here, I would move a quarter of the way across, and that would be S3. Let me stop for a second and let me know if this makes sense, what I'm doing here. Or does it make sense? Maybe tell me that. Yeah, ask. You good?
I don't know what to ask, actually.
Okay.
Yeah, I don't know.
Yes, sir.
Can you repeat this part?
Absolutely.
Yeah, that's kind of where I was at. I was like, maybe you should just redo it.
You got it. Let me start with a concrete example so you can see it. You can see what I'm doing. So let's say I gave you this alternating series. Right, and so forth. That's actually a geometric series. We could do what we wanted with that, but it's also alternating. Plus, minus, plus, minus, plus, minus. So S1 is 1. S2 is 1 minus a half. Yeah. S3 is
1 minus a half plus 4.
1 minus a half plus a fourth.
Yeah, got that.
So, and check this out, this is S1 minus a half.
Yeah.
This is S2 plus a fourth. And then S4 is S3 minus an eighth. Let me stop. So make sure that makes sense.
I got that.
Okay, we're good. So let's draw a picture. So first off, S1 is 1. So that's S1 right there. And then S2, I go back a half a unit. So let's say here's 0 right here.
You're minusing a half.
I'm minusing a half, right? So here's S2. And then I'm gonna add, to get to S3, I add a quarter.
So you go like halfway between.
Go halfway.
Okay, I think this makes sense.
Is this making
Uh-huh,
sense?
uh-huh.
And then I subtract off an eighth to get to
So
S4.
half of that.
And then you see how the rhythm just keeps going like this.
You know, like converge or something.
Yes.
Is that what we're looking for?
Yes, they kind of spiral, they go, settle down and so forth. Like that.
They're-
Yeah, yeah.
They're in a pickle.
Do we see that? Does that make sense? So all we needed for that to happen was that this is true. All we need is for these things to be that when I move this way, I have to move less than I just moved. And now when I'm here, I have to move less than I just moved. So you want to keep moving, adding or subtracting less than you previously did, and you'll settle in on something.
And this is converting to 0.
And this and converging to 0. So we need the terms that we're adding and subtracting to become less in magnitude,
Yeah.
and they must also shrink to 0. And that's it. So the alternating series test is this.
And if it doesn't, then it's not an alternating.
Exactly, yes, yeah. So the alternating series test, the AST, and I think it might be on that sheet. It is, awesome. Alternating series test says that this series converges if the terms die to 0. We've got to have that. If this doesn't happen, this thing cannot converge no matter what you're plussing and minusing. And the terms form a decreasing sequence. That's it. Yes, sir.
I just, do you, for the one that you wrote, the sum of, -1 to n, a to n, yeah, that's, how does the a of sub n go to, or decrease?
So this, like this one, let me show you what I mean here. So this thing here, this is, so here a sub 1 is 1. A sub 2 is 1/2. A sub 3 is a quarter. So the things that are being added and subtracted are the things I'm saying shrink, Yusuke.
Okay.
So like this sum here is actually sum, and we need to start at, I need to put a +1 there, so that it starts off positive, because when n equals 1, I want this thing to be positive. But let's see, and then this is actually, 1/2. Actually start at 0, we'll be fine. There we go. 2 to the end. So when n is 0, I get 1. When n is 1, I've got a half. When n is 2, I've got a quarter. But I'm treating the alternation part as like separate from the terms themselves. And so these things here, these decrease.
Oh, I see.
Does that help?
So making a sub n has to be like a fraction.
Yes.
Okay.
Yes, yeah, absolutely. Good? Let's try it. Let's try a couple. Now the thing about it decreasing, I'm not gonna be too hardcore on this. If we were being rigorous, you'd probably need to take the first derivative and show it was negative to show that the function's decreasing. We're not doing that. You'll see how this game rolls. So here's the series. Let's start with one we had right at the beginning of class to warm up with. let's write out a few. Kind of looks like a P series with P is 1/3. Right, and let's even be more clear about that. I'll put a 1/3 there so you see it. Looks like a P series, but it isn't a P series because of the alternation. The alternation makes it an alternating series, so life is really good here. Can you write out the first few terms, just to make sure we're all just thinking about it, just so that this gets embedded in your brain a little better than just nodding at it. And what you need to identify is what is the part that's not alternating. So in other words, strip off the -1 to whatever. Want to say that again? Oh, 1/, okay, yes, sir. First term, gotcha. Yeah, PK, absolutely. What's the next one?
Minus 1/1/3. 2/1.
There we go, yeah. You said you heard it immediately, and then a plus, yes, sir.
Keep going.
Exactly. Like that. So that's, we good? Let me stop. Atman, I saw you make an expression. You good? You good? Okay, all right. So the A sub n's are this part. You take off the alternation. The A sub n's are just the stuff that is being subtracted and added. So first off, do we agree this is an alternating series? Right? We see plus minus. That's all you gotta see, is that it's plus minus or minus plus forever and ever. This is an alternating. So we're gonna apply the alternating series test. And it does everything we need. First, I just have to identify what are the things being added and subtracted. So now, what is the limit as n goes to infinity of the terms? What happens as n gets bigger and bigger?
It gets smaller, it goes to 0.
Gets smaller, it goes to 0, absolutely. 1 cube root of a billion, 1 cube root of quadrillion, whatever, quintillions. This thing's getting 0, so it equals 0. Are we good with that? I hope so. That's good. Are they decreasing? So in other words,
Yes,
so can you say a little bit why?
because the bigger the denominator gets bigger.
Like it. The bigger the denominator gets, the smaller the fraction gets. Yeah, so the A sub n's are decreasing. You just note that. You don't have to prove it to me. We don't have time. But if I wanted to use calculus, I'll just show you really quick. I could take the derivative with respect to n of the general term. So this is 1/n cubed.
Yeah.
If I take that derivative, I just use the power rule. And that is this. This is -1/3 n to the 4/3. If n is a positive number, this is a positive number. So this is always positive. Now I've got a negative, so this thing is always negative. The derivative is negative. And a negative derivative means you're always going down. That's how you would prove it if you needed to. But your argument was perfect. As the bottom gets bigger, the fraction gets smaller. Perfect, beautiful, love it. So, by the alternating series test, we have condition 1, we have condition 2, this converges. I'm done. This converges. By the AST. Let's try another one. Let me give you another one. Let's apply the alternating series test.
If it decreases,
Yes.
you automatically assume it converges.
That was my next.
So say a little more.
So up there you wrote
Yeah.
that if it's a decrease, A sub n is decreasing, you just assume it's converging.
And if it's decreasing and it's decreasing to 0.
Okay.
Because I can create something for you. So for example, here's an A sub n. that is decreasing. But it is not decreasing to zero.
Yeah,
So you just gotta be careful. You need both those things.
sounds good.
Is that, yeah? See, do you see how it's decreasing?
One.
But it converges to one.
Right.
Yeah, exactly.
Add the one, yeah.
So if I was being tricky, I probably will be. Just because there's like not many ways to blow this test up that are fun. So here's your next one, please. We got a lovely marker. What was it? It was n+2 over n+7 times -1 to the n, and equals, who cares where it starts, right? We never care where series start. What's up? We never do. Except that we're doing a geometric and we're trying to find the sum. Write out a few terms. Okay, I feel like you got it. Do you? Maybe? No pressure, either. You've lifted a lot of stuff for us today. Athman, you got this one? Okay, thank you. Think you know what's up, Kevin? What's up?
Diverges,
Yes, sir. Hi, why is that?
because it's not going to zero.
Absolutely. Yeah. So,
Is it only, it can't converge to like one?
it can't converge to one.
Okay.
The terms have, in any series, not just alternating,
Has
the
to go to
terms
zero.
must go to zero.
Yeah.
So, we could do this by the divergence test. That would actually work. But we're using the alternating series test. So this thing here, these are the a sub n. Strip off this alternation. So the a sub n's are just this. Kevin, what's that limit as n goes to infinity?
1.
That is 1. So eventually, when n is really big, it's like you got +1, -1, +1, -1, and that isn't going to settle. Does that make sense?
Yeah.
Yeah? So, since a sub n goes to 1, which is not 0, the series diverges. By the alternating series test, or you could say divergence test if you want. We got one last one. But I'm gonna twist this one up. Put a minus in there. Take a minute on that one. And use the alternating series test. You could make some other conclusions using geometric series. Yeah, exactly. So you kind of know what the answer is geometric series wise. Yeah, try to think with the AST. feeling very positive about how this is all going to roll for the rest of the semester. And I still haven't learned my lesson. I'm still propping that thing up with things. It happens. What's up?
Oh, no, that makes sense.
Are you okay, Alexander?
Yeah, I wanna see you do this problem though.
Okay. You will. Does this look okay with the way I wrote this to everybody? I kind of just distributed the powers. Is that what's disturbing you?
No, that's not.
Okay.
at all.
Cool.
That, I understand.
So what is the a sub n without, so first off, notice I could write this like this. I could literally pull the -1 to the n out. And it still gets me the alternation. So what is a sub n here? It's this thing. E over pi, I'm gonna write it like that. Now, this part might get a little tricky. Seeing that that's decreasing, right? But can somebody give us an argument that it's decreasing? That, and we could do it with just one. If we can actually just convince ourselves that this is true.
Which I would agree.
Yeah, we can just multiply both sides. We can cascade it down. But if we can convince ourselves of this, we got it. Can somebody convince us of that? Why that is true? Without calculus, we don't need calculus. Yeah, Ahmed.
Since the pi is like is greater than the e,
Yeah.
and we like we do the n,
Yeah.
so it multiplies every time, and the pi gets bigger than the e.
Yes, we have to be a little careful with that, but you're on the right track, absolutely. I think it's easier to think about this thing inside here as being a number that's less than 1.
The whole fraction gets bigger, which is closer to 0.
Yeah.
Closer to less than 1.
I'm having the same problem with the language you were using as I was with Othman's. That's okay.
I know.
This is a fraction.
Yeah, e over pi, so when you make that
Yeah, okay.
bigger,
Yeah.
if you make e over pi bigger, that number becomes smaller. What am I missing there?
Well, it's just it's the language.
I know,
I'm not
I know
quite
it is.
sure. When you say when you make it bigger, what do you mean?
So if you square it,
Okay, so
or
let's,
cube it, or anything, it
okay,
gets
so
smaller.
like this. Why does this get smaller?
Because the denominator will get bigger. A sub
bigger
n
than
decreases.
the-
Is that what you're looking for?
So will the.
I'm not hearing the thing that really will satisfy my soul, but I think we're on the right page. But I think the language is not hitting.
Can you ask it a different way? One more time.
No, he's looking for it specific.
For a specific order.
Yeah.
I'm not kind of like.
What do you? But I don't know. Okay.
Yeah, and it's cool. How can you know? How can you know what's in my heart? You know.
No, it's fine. I probably know the word.
I think we all know. So this is a fractional number, right? This is a number less than 1.
Correct.
It's like taking a percentage of something. You're
Yeah.
taking a fraction of it. If you take a fraction of something, this is literally taking like 2/3 of this.
Fraction of a fraction.
This is pulling a fraction of this away. This is like a percentage of this. Does that make sense?
Yeah.
It is a fractional amount of the original. So this is a fractional amount of this. We have to be careful when we're saying the bottom's getting bigger and the top's getting bigger, because you have to think of it all as one. That was the language that was like, scares me.
Alright, I got you. I see where you're.
You see, so like,
in this specific
yeah,
circumstance.
like if I had this, and this is almost kind of the same thing, if I had this versus 2/3 squared,
Yeah.
this is 2/3 of that,
Yeah.
and so it's smaller.
And so then we're.
So we have to say that
2/3
it's a part of it.
Yes, a part of it. Yeah, a part of it. Yes, it's a portion of it or part of it.
Yeah.
Yeah, so like if I had 0.99 versus 0.99 squared, this is 99% of
Of
that.
that 99%.
Yes.
Yeah.
That's kind of that's the way I was wanting to hear it. It was all good. You guys, I knew you saw it. It just,
Yeah, I feel like I still understand it the same way. Should I be like thinking about it differently?
no, you're fine. Use the word fractional.
Yeah,
I'll be a
I like
happy
that word.
camper.
No, it's all good.
Yeah, yeah.
It's a good word.
So, so look, since this is true, if I multiply both sides by the same number, then it's also true. So if I multiply both sides by e over pi, then this becomes this, and this becomes this. And, oh, cute.
I was like, yeah.
And I already knew this, so I can convince myself that this is a chain of things that's getting smaller. Now, why do I know it goes to 0 and it doesn't do something weird like that weird example? How do I know? And this is a result that maybe I gave you guys. Maybe I gave you, it's not on this sheet. It was like when we talked about geometric series. What is the limit as n goes to infinity of r to the n? There was two possibilities.
0, 1.
0 or
1.
or divergence.
Oh, right, divergence, right.
So I guess it could be 1 if r equals 1, you're absolutely
I
right.
agree, I like the divergence thing better. That makes sense in my head, actually.
And it diverges otherwise. So this is true if r is a fraction.
Yeah.
Because you keep taking a fraction of a fraction, it's eventually gonna get down to nothing. As we watch our savings dwindle, right? I keep pulling money out of my savings, I pull 10%, 90% of my savings is left every time I go to the bank. I'm gonna get down to 0 savings at some point. So this result right here, let's just summarize it. There's an easier way to do this one, and we're gonna do it in just a second, but this is decreasing. We convince ourselves of that, and a sub n goes to 0. So by,
Goes to 0 because of the r to the
because of this deal, yeah, exactly, because of that result. So by the AST, this converges. What other way could I approach it? As a geometric series. So another way, so this is the AST, but it's also geometric. And sometimes it's cool to be able to see things in multiple ways. What is R?
R is
E over pi.
E over pi.
Is it that?
It's E over pi negative.
Negative. Yeah, because it changes sign, right? And we taught this number is less than 1, so this series converges. What does it converge to?
1.
Nope. How do you find the sum of a geometric series?
Oh, no, it's
Yeah.
not 1.
First term is 1.
First term over 1 minus r.
Plus,
Like that? Yeah. And then if you want to simplify it, that would be pi over pi plus e. So it's similar to the other one. Multiply top and bottom by pi, clear the fraction, blah, 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 blah. Okay, I wanted to say one more thing about this. If we take a series and I slap absolute values on it, and in other words, I strip off any alternation that might occur, converges. So this is strip off alternation. Strip off the plus minus, converges. The series is absolutely convergent. And that's a new term. So I want to go through, when you have an alternating series, one thing you want to ask yourself is, okay, so this converged, is it absolutely convergent? Is this series absolutely convergent? So what does this look like absolutely? So let's ask this here, absolutely convergent? We're going to put a question mark. What does this series look like in its absolute form? What does it look like? Every minus becomes a plus. Yeah, does this look okay? Does that converge? Careful, just
If
take
we
a
do
second.
this with the absolute.
Yes, yes. So I stripped off, is this convergent, this thing right here? What kind of series is it? P series, P equals what? 1/3? Does it converge or diverge? Diverges, because that is a divergent P series. So this is a P series. So its absolute form is a P series. It was an alternating series itself. It's P series with P equals 1/3, and so it diverges. We have a term for this. The original converged, the absolute form diverges if the original, this is the last thing, original converges, but the absolute version diverges, because this happens a lot. This series is called conditionally convergent. It's conditioned on being the way it was. When we try to change it, it doesn't work anymore. The series is conditionally convergent. And there's some weird stuff that happens with a conditionally convergent series. So this guy is conditionally convergent. So now, let's answer that question. Let's decide, are the rest of these conditionally well, that one isn't even convergent. So we're done. Once your series diverges, it can only get worse. If this doesn't converge, and then I just make everything positive, that's worse. That's just piling up even faster. So this thing diverges. It will certainly, we don't even answer the question, so just make a note. If a series diverges, we're done. That's it. We don't have to do any of this other stuff. Is this conditionally convergent? What is the absolute version of this series? So let's take it. So here's our original. Yeah. So the absolute version is that very first one I gave you. Just take off the minus. Let me stop for a second. Do you see what I mean? That this is the absolute version of this. Take off the minus. Does this converge?
Yes.
Yeah, we did. That was the very first thing we did. So this converges. Absolutely. So we have one that converges absolutely. It converges on its own. We have one that is divergent. And we have one that is conditionally convergent. Quick question. Your turn. Does this series, I'm going to give you a series. This is the practice. What's up? Well, Jose, what's your question, my friend? Oh yeah. Let's talk. Yeah. I'm sorry, I didn't mean to take you.
Okay, so for it to converge absolutely,
Yes, sir.
both the original and the absolute.
Yeah, that is true. Yes. Yes, 100%.
Gotcha. I'm getting
Well said. You're getting it. Yeah, very nice. I know I'm gonna be. This is an alternating harmonic series. Do me a favor. Does it converge? Then tell me, is it conditionally convergent or not? Oh wow, I missed a turn. God, I got a little. Yeah, sorry, can't count.
Or
Oh shit, it still can't count. Okay, 1, 2, 3, 4, 5, 6, 6. Yeah, got a little excited.
I thought you just did it for fun.
Oh, yeah,
You're
I
like,
did.
oh, no trick
I
here.
did. I was just being tricky.
Okay.
We're deciding if that series is conditionally convergent or not. Alexander, I don't know, I think you might have left out right as I was doing that definition.
I just read it.
You got it, okay, cool,
Yeah, yeah,
okay,
yeah,
awesome,
yeah.
good, good. And if someone thinks it converges and has Excel and wants to get the sum of this approximated, that would be peachy keen. I guess I'm hinting that it does converge on its own.
You said peachy.
Peachy keen, never heard that? I mean, a man who watches Tom and Jerry doesn't know peachy keen.
What is that?
It's, I don't know. Have you heard that expression, peachy keen? Oh, that's just old hick talk, I guess, from southern Illinois. I'm from southern Illinois, yeah. The people in Chicago think we sound like hicks. Think we have a drawl. We don't talk fast enough for those Chicago folks. Now I gotta look that up.
It's one of those things you've always said but never,
Yes, pretty
never knew
much.
what it meant.
Pretty much, until you're like, what? It's in Webster's. I'll be damned, it's in Webster's.
Okay, awesome, and blue chip.
Wait, what was that one?
Blue chip.
Blue chip.
I still don't get it. How do you use it?
If I make a bunch of money on crypto, cause it's going up this week, that'd be peachy keen. If you smoke the final, you get an ace, you ace the final, that's peachy keen.
It's awesome.
Awesome, absolutely, just replace, yeah.
It's replacing.
Pretty much.
Kellen, what do you think about that series? Do you think it converges?
Yeah, that one converges to the absolute converge.
Cool, let's talk. So tell me why this converges. I agree.
Cause AN is one over N,
Yep.
and if limit is N goes from infinity to one over N.
And it's decreasing.
And it's,
Yeah.
yeah,
So that's decreasing in the limit.
So ace of N is decreasing, and notice that nice little notation there, makes things speedy. Ace of N goes to 0, so by the AST, it converges.
I hope it's not conditional.
But then, what was that you were saying? The absolute version is this.
yes.
What do you think about that, Kellen?
I don't like the absolute. I think it converges, but well, I guess the divergence test would be the.
Does the divergence test apply here?
I don't think
I guess
so.
it doesn't.
It doesn't, yeah.
I don't think.
Because the terms go to 0, right? So like, what kind of a series is it? Not geometric. So like when I ask, here's a tip. When I ask what kind of series is this, it's probably geometric or P.
Oh.
What kind is this?
I was thinking P series, but I didn't actually think about it. P series.
You almost got it, Kellen. Like with here, so let's see. So here's the absolute version, right?
Yeah, I agree.
What's P there?
One's
What?
the
That's
And so it diverges. It's the harmonic series. This is the borderline series. PK, let's talk.
I didn't think about it
I
like
see that expression. Where you lost at? Tell me where you lost. Oh, because it's n to the first power. So if it were this, that would be p equals 2. You see now? Yeah, awesome. So we have p equals 1. That's a tricky one. That's a tricky one. Thanks, Kellen. Thanks for helping me out with that. This is the harmonic series. The one I got all excited about with the guitar strings and all of that shit. This is the borderline. If p is bigger than 1, it converges. So if I got a p here, and it's 1 or less, it diverges.
less
If it's
than a third anchor.
yes. So this is the harmonic series, and you should be able to identify that. The harmonic series is this beauty right here. It's 1 over 1 plus 1/2 plus 1/3, blah, blah, blah. Harmonic series diverges, and know that fact. So this series is conditionally convergent. Let me stop there. Conditionally convergent. Does that make sense?
So does the original
So it does
diverge?
converge
No.
conditionally.
The original converged,
And
and then as soon as we strip off the minuses, it diverges.
Oh, which makes it conditionally convergent.
Yes.
Gotcha, that makes sense, actually.
Yes.
The condition of the minus. Alright.
Now I'm gonna tell you something insane as soon as Jose asks this question.
So you said, no, never mind, I don't even need to ask it.
You sure? Ask it.
No,
Okay, alright, fair
No.
enough. Okay, trust you on that one? Okay,
Yeah.
alright, I'll do it, I'll trust you.
it's right there.
So a conditionally convergent series has a crazy property. And it absolutely, if I have an absolutely convergent series, then what is the commutative law of addition?
A plus B equals B plus A.
A plus E equals B plus A. You can add in different orders and get the same thing. If I have an absolutely convergent series like this, and then and it's alternating, so we got like this.
Isn't that like the original?
Yes, yes. So do you see that this is?
Wait, no, it's not.
So here, if I give you this series, can we tell by the AST that converges? If I plus,
Yeah.
do you see it converges?
Yeah.
The terms go to 0
A so then decreases.
and it decreases. So by the AST, this thing converges. But as soon as I put on this, what kind of series is it?
a harmonic series.
Not harmonic.
P series.
P series with P equals what?
2.
2, and that converges. So this series here is this is absolutely convergent. And like Jose said, that once you have an absolutely convergent series, the original also converges. Because the original had minuses. At least you had a chance of stuff becoming less in the beginning. If I have a conditionally convergent series, I can't rearrange it and get the same answer. So this is mind-boggling. I can rearrange this series to add up to anything you want it to add up to. You tell me what you want this to add up to. There's a proof of this. I'm happy to share it with you. We're not going to do it. You would like this to add up to pi. I can rearrange the terms here to add up to pi. If you'd like it to add up to e, I can rearrange the terms to add up to e. What's your favorite number? 7. I can make these add up to 7 by just manipulating it in the right way. That's madness. That's crazy. And if that is all like, you're like, that's so crazy, I want to know more, tell me. If you're like, that's so crazy, I need to get the fuck out of here, you're welcome. You can leave. That's the end of class. Yes, sir.
I saw the question last in the P series. I still don't see like the P.
I don't either.
Right here?
Yeah.
Okay, so let's look at P series. So P
No, like
Oh,
there and there.
Oh, in the harmonic series?
In the harmonic.
It's
Oh, because it's so the exponent is a 1 here.
It's this
What is
sneaky.
But it's equal to 1. So how does it converge?
That's what I thought.
The original converges because it's alternating. But when I make the absolute version, see, this wasn't a p-series. This is an alternating series, but it's not a p-series. P-series don't go plus minus plus minus.
Okay. But when the absolute series,
Yes, sir. But the absolute version is a p-series. And that is the p equals 1 case.
so when it equals to 1, does it convert or that?
It diverges.
Okay.
So when I have this thing here, 1 over 1 to the p, plus 1 over 2 to the p, 1 over 3 to the p, 1 over 4 to the p, blah, blah, blah. When I have that, when p is bigger than 1, it converges. And
Strictly.
Strictly.
Okay, gotcha.
Strictly bigger. Yes, there you go. Maybe that was what was the trouble. Yes, sir. All right, guys. Good work. I'll take care of you, I promise. It's gonna be okay. Are you all right? I don't know. We might have to carry Alexander out.
No, it's good.
It's okay. It's a lot.